Hello and welcome. We are looking at measuring angles. Let's start by defining an angle. Although you might have some ideas of what angles are, let's kind of apply a geometric definition to it, or at least good enough. It's the amount of turn that's formed when two lines, rays, or segments intersect at a point. So here I have two lines. I could call this, say, line DB, and I could call this line AE. And as we know, two lines can only intersect at exactly one point, and this point here I called point C. So let's say that you are standing in a tree and you're looking at someone below you, and they're facing a certain way. Let's say they're facing toward point E, and you ask them to turn a certain amount. So you turn. Now they stay where they're at. They're just turning their facing, if you're standing still, but moving along, and you go to point D, you're looking that way, you have turned a certain number of degrees, right? You have created an angle for yourself. Okay, now that's what angles are. So I'm not saying that everything turns, but everything has a certain amount of turn before that angle is now defined with a certain amount of degrees. The common endpoint, that point C in this case, that the intersection shares, this one and this one, this is called the angle's vertex. So C here is called the vertex, right there. The two parts where it sticks out, these two rays, CD and CE, or the segments here, these are called the sides of the angle. So an angle has two sides and a vertex, always. It might not be as easily noticed, and I'll show you an example of that later. If you want to name the angle, if you want to write it down, you're going to use a side, a point on each side, and then you're going to say the vertex as well. So I would start by, if I wanted to name this angle, I could say point D is on one of the sides, point C is the vertex, point E is on the other side. This is angle D, C, E. You could also start with E and go angle E, C, D. But the common theme here is side, vertex, side, vertex, side. Vertex is always in the middle. If there's only one angle in the figure, it can be identified using only the vertex. So what does that mean? Well, in this particular case, if I didn't have this other part grayed out, it would have looked more like there were four different angles. And in fact, there are. There's 1, 2, 3, 4 different obvious angles being made. But what if there was only just one obvious angle being made, such as this one right here, and I called it OGHI, like that? I could just call this one here angle H. I don't have to call it angle GHI. But for better practice, we are going to be using 3 letters instead of just one. Okay, redefining angle, once again, it's the amount of turn formed when two lines, rays, or segments intersect at a point. So let's go ahead and give more examples besides just that one, and let's say what different kinds of angles they actually are. Let's give them different names. All right, so angles are measured in degrees. We talked about that, and I think you have an understanding of that. 360 degrees is a full circle. So how does that work? Well, if I start at this point right here, if I'm here and I'm looking out this way, and I go and rotate my body, I'm turning, and I end up right back where I was. I've made a full circle with my body, and that is 360 degrees. As you can tell, that also looks like a circle. And again, I'm standing right here looking in this direction. The angles that I'm drawing right here isn't somebody walking this way, it's the path at which your eyes are locking onto, maybe an object that's moving that way. And oh, by the way, there are also radians here that goes up to 2 pi. We're not going to be talking about that much. That's more of a term that you'd see in, say, a calculus class. It's used with a lot more trigonometry. Right now, as you're doing this, you're probably just looking at this in terms of degrees. So 360 degrees, which means 180 degrees is a half circle. All right, let's look at our individual angles. Now, before we do, the greater the turn amount, the more degrees of the angle that is measured. So as you can see, X is a smaller angle than Y or W are, so X is going to have less degrees in the actual angle. So angle X, or if I could also name it angle DCE or ECD, as you saw before, it is less than 90 degrees. Now, I think everyone kind of knows what a 90-degree angle is. Think of the floor meeting with a wall. It's going straight upright. There's a 90-degree angle. You can see that X is less than that. This is also known as an acute angle. Okay? Anything that's between 0 degrees and 90 degrees is acute. Angle Y, it's this guy right here, which I could also name BCE, or I could name ECB. Well, it's greater than 90 degrees, right? It's more than that right angle, but it's less than 180. If you remember, I just talked about 180 being a semicircle. It's half of a circle. Well, this is less than that. It's not quite a straight line. This one is between 90 and 180. That is also called obtuse. Okay, so an acute angle, once again, is one that's between 0 and 90 degrees. It's not always exactly looking like that. It could look like that as well, right? But it is less than 90. And how do you remember that? You say the word acute, and you say, it's acute. It's little. It's so acute, right? And then obtuse, it's like obtuse, right? It's just bigger. That was just the way I always remembered it in middle school. However, if you say them enough, I think you'll remember what they are without having to do that little thing with your voice. Angle W, now angle W is described by this full angle right here. I wanted to make sure you didn't think it was just this one, but that it was this whole thing right here. I could call this angle BCD or angle DCB. You can tell, though, it's not really an angle. It's kind of just flat. It's exactly 180 degrees. Those are known as straight angles. All right. Now, I understand how that's kind of strange because you're like, well, isn't that a straight line? Is that not an angle at all? Yeah, but technically, I think everything kind of has an angle to it. If you wanted to assign a vertex and compare it to others, you do know it has 180 degrees. That's how much turn was formed. So it is still an angle. It doesn't angle quite the same way that we see angles, but it is. And finally, let's look at this right angle right here. Right angle is exactly 90 degrees. Most often, you're going to see this little thing right here, which represents it. It's that kind of squarish look that says it's 90 degrees. So make no mistake, even this one right here, even if it doesn't look exactly 90, if I mark it as such, you have to treat it as 90 degrees. That's the thing that tells you that it is. Or if they say that it's a right angle, then you could make that mark. All right angles are congruent. That's another Euclid postulate. So all right angles are 90 degrees. So let's do some examples. I have parts A, B, and C here. We're going to assign a name to each angle. And then we're going to use a protractor. So you haven't used one of these before, maybe. I don't know if you have. But I'll use my software protractor here to find each angle's measure exactly, or near, very close. And then we'll decide whether it's acute, right, obtuse, or straight. You might be able to see what they are here, because technically here, these are drawn, quote unquote, to scale. Like even if this didn't look 90, if this is measured as 90, we will call it a right angle, only because of the measurement. So let's go ahead and assign a name to each first. Let's do that one at a time. So this one is angle JRG. Now I could have just called this angle R, right, because it's the only one of its kind, or I could have called it angle GRJ. But let's try with 3-letter names. So angle JRG or angle GRJ. This one right here is called angle QFA or AFQ. And this one right here is called angle ZTH. Notice how there's another point on this ray as well. I could have called it ZTP, or I could have done HTZ or PTZ, right? So it doesn't matter which point here, but I don't want to call it angle PTH, for example. That wouldn't make any sense. I need to draw it to this next point somehow. So you can use either point on there to make it happen. Okay, now let's use the protractor. So here's what a protractor is. You see these numbers right here. They represent, compared to a reference point, okay, such as this green guy right here, when I compare it to 0 degrees, how much angle is being made by the other guy right here. Now this software will allow me to mark exactly where to go, so I'll try that out. But when you do it, you'll try and do the best you can. So how do I measure it up with this? Well, I want to probably try my best to line this up alongside one of my sides right here. And as I do, I want to line up the middle portion right here with my vertex R. So as that's lined up, at least as best as I can, you now look at where this one is shooting out to right here. So as you look at that, you'd say, oh, it's really close to 35 degrees, maybe 34. But how much is it near exactly? Let's go ahead and put that right there. Yeah, close enough. Let's see, maybe up there like that. Okay. And then I can click, so that angle stays the same. I haven't changed it. If I click this little guy right here, because it was off the screen, you'll see it's about 33 degrees. So it wasn't quite there, but That's close enough, right? That one's about 33 degrees, so let's call that 33 degrees. Now, it doesn't matter if I went from this way to there or this way to here. That's still a 33-degree turn for angle JRG. Okay, let's check out the next one, angle QFA. Is this 190 degrees? Well, as I line this one up with ray QF, right there, okay, let's check it out. Let's go from, whoops, let's bring that there. Let's bring this here. Now, if I did measure it up perfectly, it should say, 90 degrees, good. So I measured it right. That one is 90 degrees. As you can see, it clearly lines up. And so this one here is 90. And the last one, look, there are different ways you could do this. For instance, you could do your rotation as you did last time. Like I could rotate this exactly like that and try and find that. But what if I'm really bad at lining this exactly up, right? What if I'm not good enough to do this? Well, let's do this way first. Then we'll do the other way second. So I'm going to line this up here and try and get this as close as possible and see where I'm at. Now you can see from here, if we start at 0 degrees here, this is going 10, 20, all the way, there's 90, 110, 100, 110, and about 120. Seems very close to that, if not exactly. So, and super close, 119 degrees, right? Now, what if, though, you weren't very good at lining it up this way and you were using the software and you could only, pretty much you were only good at laying it flat? Well, here's another thing you can do with angles, and it kind of ties in pretty well with what I'm going to talk about next, which is the angle addition postulate. If I go ahead and lay this flat alongside here, just like that, so I'm still on the vertex. Now I have two angles here. They're not going from 0, though. Notice this one, I mean, if I were to be close enough, I should get close to 119 this way. If I were to get close enough, I'd say this is about, let's say, 33 degrees, 31, 32, 30, maybe 34. Let's call this angle is at 34 degrees from here. Let's see if I can move that out of the way. 34 degrees. Bringing it back, if I now go a little more over, all the way over here and show how much turn I got from 0 here, this one's at about, let's shrink this a little bit. Notice this one's at about 152 degrees. So this one here is 152. So you have two angles. If I kind of just put that stuff out of the way here, once again, I drew an angle here from a vertex that was about 34 degrees. This one went over this way. This was about 152 degrees. I need to find what this angle measure is between 34 and 152. So the question is, if 34 is your new 0, in a way, how much did I go from 34 to 152? So you're going to do 152 minus 34. The bigger minus the smaller. You could do the smaller minus the bigger and get a negative number, but make sure it's then the absolute value of it. So the angle of one minus the angle of the other gives you 118, really close to 119. I should have probably picked 33 degrees there. But you can see that 118, 119, whatever, it still applies. It's still about the same angle, as you can see it clearly lined up. Okay, a lot of writing on this wall right here. Let's go ahead and go through them one at a time. I'm using kind of my angle again that you saw before, my one set by these two lines, okay? But I added two more rays to make use of them. We're going to talk about the angle addition postulate and different special angle names besides right angle, stuff like that. We want some ways to identify certain pairs of angles. Okay. First, the angle addition postulate. That's what this part is right here. Angles sharing a vertex can have their measures added to find its measure, like its total measure. And the measure of the larger angle is the sum of the measures of the two smaller angles. So, what does that mean? Let's go ahead and take a look. We could use a protractor here, but you have this angle, DCE, the entire one. G is a ray that's drawn down the middle. Now, when G is drawn from point C, sorry, I should call it CG, this ray CG means it does start at C, then I have kind of created two new angles. Here's an angle DCG. The measure, this M means measure, the measure of angle DCG, let's say it was about 30 degrees. Let's just be cute with it. Let's say it was 30. Okay, here's also another new angle formed right here. I'm going to use 2 marks to indicate it's different, not necessarily congruent. This is called angle GCE. So the measure of angle GCE, let's say it was about 25 degrees. Let's do 20. Let's get good numbers. If I added these 2 angle measures, that will give me the total measure of the original angle without that drawn, angle DCE, which in that case should be 50 degrees, right? You can add the measures of these 2 angles as long as that ray is drawn straight through and there's no other gap between them. I can add the 2 and I come up with the original measure, the total measure of the original angle. So 30 plus 20 is 50. The newly drawn ray does not affect the entire angle's measure. Okay, just because I drew that and broke it apart doesn't mean you can't add them back up again and get it back. So that's all that means for the angle addition postulate. Now let's use some other ones with the angle addition postulate and kind of make more things happen here. Here's another ray called CF, okay, that I drew out here. And when it's drawn, I'm marking, and I don't know if it's perfect, but I am marking that this is a 90-degree angle right here. Now, what did I say before? All right angles are congruent. So if this is a right angle, and this is a straight angle, or better yet, a straight line, then that means that this right here is also a right angle. Okay, that's important to note, because what if they asked you to add the measure of angle DCE, which again I was pretending like it was about 50, but let's say that I was adding this angle measure right here, DCE, with the measure of angle ECF, that's this guy right here. When you add those 2, they're trying to ask you, what is the total angle measure? Now, you might not know what angle DCE is, right? I have no idea. I said it's about 50. Then in that case, this one's probably about 40. But I do know that when I add them together, I should be getting 90 because this one was 90 right here. So the measure of angle DCF, this entire guy right here with the ray drawn, is a right angle 90 degrees. Now, here's another relationship with these 2. These angles that add up to 90 degrees, they are called complementary. They're complementary angles. They complement each other. I guess that's how it works. Other things that are complementary in life, if you think like milk and cereal, right? One is needed for the other to make happen. I don't really know why they call it this necessarily. I don't know if this angle needs this one, but to make it 90 degrees, that is true. Okay, next one, the measure of angle BCA. Let's go and draw that vertex first. Here's BCA. BCA. Plus the measure of angle ACD right there. As you saw before, this was what angle W was before. It was that full 180 measure of angle BCD. Okay, we know it's 180, but using the angle addition postulate, you can see that that forms angle BCD, 180. Now, angles that add to 180, angles that make a straight line, are called supplementary. And if you've used the word supplementary in life, you would literally say that's something in excess of, it's in addition to. So it's not needed, I guess, but it's very useful to have. Just like these videos right here. If you take a class, these videos are probably supplementary to what you're learning. Not necessarily required, but good to have. So complementary is 90 degrees, supplementary is 180 degrees. All aforementioned angle pairs are also known as adjacent angles. So the 3 different angle pairs that I gave you, here was the first one. Okay, those were called adjacent angles. Here was the second one. These are also, let's see, it was this one and this one. And then the third angle pair, let's use a different set of colors. Let's use green. Third angle pair here, these are all called adjacent angles. What are they? They're basically angles that neighbor each other. They have the same vertex. They're on the same plane. Okay, and they essentially have a ray drawn through them to match them up. So you see the red right here, CE was the ray for this angle right here, DCF. They're on the same plane. They're both on my screen right here, like 2-dimensional, flush on the screen. They're called adjacent angles, so that's their pair name. There are some other ones, such as this one down here, that are called vertical angles. Vertical angles are angles that are opposite one another. In other words, they have opposite rays extending out. So kind of like two straight lines going through. For instance, these are vertical angles. DCE and ACB are vertical angles. Now, they match up congruently. Vertical angles are congruent. They're both the same angle measure. Just like right here, angle ACD with angle BCE, these are also vertical angles opposite one another with opposite rays. They are also congruent to each other. So if this one was 50 degrees, then this one's also 50 degrees. If this one right here, this is just some practice for you, how much would this one be? If this entire thing is 180 degrees and this portion is 50 degrees, you can kind of use that angle addition postulate and say 180 or 50 plus this one is 180. So 180 minus 50 is 130. And if this is 130, then this one here is also 130 degrees. And total, that should add to 360. You can add to confirm that. What do we name the measure of angle DCA plus ACF? Now this one's kind of tricky because we've been talking about angles as far as having that vertex thing. So check this out. Here's DCA. Okay, let's add ACF to it. Okay, now if we used our different numbers that we were just using, like 130 plus 50 plus 90, this would be, plus, yeah, I guess it would anyway. This is 270 degrees, this angle. The difference is, though, do we call this angle DCF? Because I thought this was DCF right here, right? I thought DCF was 90 degrees. What about this guy right here? Well, the truth of the matter is, you can find the measure of this angle, but it's very, very not often that we will be referring to the outside angle, if you will, or what it's also called when they're greater than 180 degrees, convex. Convex angles are the angles that are measured when you're sticking it out in some way, right? So say that you're looking like at some shape right here. I'm drawing this thing, do. This is a concave angle, angles that are less than 180 degrees, the default ones. This is concave, concave, concave. This one here is convex. Okay, it's greater than 180 degrees. It's it's sticking more outward in a way. So those are those different angles right there. So we wouldn't name it angle DCF. It's better to just give it something like that, DCA plus ACF. But like I said, most often you won't name it like that. And if you do need to, just refer to it as the convex angle, not the concave one. By default, we're going to be assigning to concave angles or straight angles only when we refer to those three-letter names. Okay, so DCF is this one, not that one, not by default. Okay, some last examples here. In the diagram, let's identify pairs of angles that are related as follows. So complementary. How are we going to find complementary angles? They are angles that add to 90 degrees. Okay? Now you can only go off certainties really. For instance, they give us a certainty that angle BPD, now B and D aren't necessarily points on this, but they are named as such. So this ray PB goes out this way, this ray BD goes out this way. So this is angle BPD. Okay, but what are pairs? So angle BPD is 90 degrees, but what are two pairs that are complementary? What two angles add up to 90 degrees? That's BPC and right here, angle CPD. So these two, when you add them up, you get 90 degrees. There aren't any other ones that I could say for certain that are. And even as you look at them, they don't appear to be 90 degrees either. So that's the only complementary pair that I see right there. Okay, supplementary pair, angles that add to 180. Basically what you'll need are two sets of straight lines, and I just want you to name pairs. Now you can have a lot of different pairs based on this because there are multiple angles. For instance, if you see any line like this one, GC, all the way through, and there are angles that are dividing through it, then you could say that there's a pair of supplementary angles, such as this angle here. So add to 180. So this angle here that I drew is angle GPA. Hey, GPA. And if I do another one that completes the 180 degrees, such as this one here, this is angle APC and angle APC. Those two are supplementary angles. Now, that made angle GPC right the full way. There are other ones, like on the other side I could have used, such as angle GPF and angle FPC, just like that. Those two add up to 180 degrees. There are also other pairs within there that I could have used. So just like I did GPA and APC, I could have done GPB and BPC. Those are also supplementary. They're different angles. They make the same straight angle, but they're different. So there are a lot of different ones you could do just with that set alone. Where's another set? Well, let's take a look at, I'll use a different color. Let's take a look at this one right here, line BF. I can do this angle here, the right angle, BPD. Oh, you know what? That helps me find another complementary angle. I should go back to the 90 degrees here, by the way. Take a look at this. This is another right angle. If this is a straight line, then this, and this is a right angle, then this also must be a right angle. Now, two right angles are always supplementary, right? 90 plus 90 is 180. So I should have added on this one angle DPE and angle EPF. That is also two complementary angles because they add to 180. Now, going back to why that mattered here, if I did angle BPD, right here, the 90 degrees, and angle DPF, that's also supplementary angles. Now, I could have done any other combination of the angles in here, such as this one with this one, right? That still gives you 180. Doesn't matter, just any pairs. You can do a bunch of them or very few of them, but I want pairs, okay? I don't want groups of 3 right now. We could ask for that, but we're not going to. Just 2 different ones. Okay, vertical angles. Now, we didn't do too much about vertical angles, but you do remember that it, hopefully, you got to take a quick look and you saw something like it had opposite rays. So say that one with that one creates pairs of opposite angles, such as right here and right here. So as I draw that, that's angle AP, I don't know what letter that is, APC with, so this one, with this angle right here, angle GPE, I think. Those are vertical angles. Boom, 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 boom. Those are congruent. Another set in this case would then be angle APG and angle, so this one right here, and this one right here, CPE. Okay, those are also vertical angles. So there are a lot of different sets that you can find. That just happened to be one set and amount of vertical angles. I could have done another pair doing 2 different lines that are drawn through, such as BF with line GC. Now you have other sets of vertical angles like these 2 and these 2. So it's all about naming them afterward. So when you have opposite rays, pairs of opposite rays going out from the same endpoint, altogether, you will have found vertical angles all the way. Adjacent angles, any 2 that are neighboring in any such way, because they all derive from point P. So such as these 2, angle BPA with angle APG. Now, I don't know what the actual measurement is, but I do know that they are adjacent angles. They neighbor each other, same endpoint, same plane. Same with these 2, which also happen to be complementary, angle FPE and angle EPD. Okay, so any 2 that happen to neighbor each other in such a way. Now, like I said, they're also complementary, but they are also adjacent. Fiend.